In this question, it is given that two ends of a conducting rod of varying cross section are maintained at 200 degrees Celsius and 0 degrees Celsius respectively, as shown in figure, in steady state. So we can just assume that this is like different resistors which are connected in series. So in this situation, so we know that in series combination, same heat is going to flow across the any cross section of this conductor. So just remember that across any cross section, the rate of flow of heat energy will be same. It will not change with respect to the radius. So the value of dq by dt will be equal to a constant across any cross section. That means same amount of dq by dt will be there across this one or across B, across C, across D, etc. Now we can observe that what is changing over here. This area of cross section is keep on decreasing. So we can write from the equation for resistance is equal to rho is equal to R is equal to L divided by Ka. As the value of area decreases, we can say that the resistance is keep on increasing. So if you are taking an element over here AB, its area is more as compared to element CD over here. So we can say that definitely the resistance of element AB is less than the resistance of element CD. So we can just imagine that the current is same if you are just comparing it with respect to current electricity. So just for calculation purpose, if I am just considering that resistance over here is equal to R, then resistance over here I am just taking it as nothing but 2R, because as the area decreases, resistance is going to increase, and same current is passing through both the resistors. Just for understanding, I am just taking it like this. So we can observe that the what parameter is going to change, resistance is going to change, then the potential difference is going to change for the same x, means we are taking L as constant. So the potential difference across this resistor, we can take it as V is equal to I into R, and potential difference across this one, we can take it as V is equal to, let's say, V2 is equal to nothing but I into 2R. So we can say that on this element the potential difference will be more. Now we can observe each and every options. So we can say that while comparing with the current electricity and heat transfer, potential difference is similar to difference in temperature. So where there is a difference in potential is more, there the difference in temperature is more. So we can say that across the element AB, the difference in potential or difference in temperature will be less as compared to the temperature difference across CD. So we can write temperature difference across CD, because the resistance is more, current is same, will be greater than temperature difference across AB. So temperature difference across AB and CD are equal, which is wrong. Temperature difference across AB is greater than that of CD, which is wrong. Temperature difference across AB is less than that of CD. So that option is correct.